Welcome back students. This is Megasham Raju, Engineering College Bikaner, Assistant Professor in Mechanical Department. So this is last lecture for the surface metrology. So we have seen how to measure the surface texture like roughness, waviness and finishness of a particular workpieces, and how to identify the lay of a manufacturing process we have seen, and we have seen the different terminologies, then analysis of the surface traces, what are the three methods: root, mean, square, central line, average, then 10-point height average value. Then we have compared with different manufacturing processes what will be the roughness ranges varying from one value to other value. Then a specification of surface texture characteristics we have seen, and then method of measuring surface finish like stylus system of measurement, which is one of the famous method. For that we are having different types of instruments like with the skid, without skid. Then after that, popular stylus probe instrument used I have discussed, which is nothing but a Tomlinson surface meter, which is purely a mechanical device. Then after that, Tyler Hubs and Tyler Surf I have discussed, which is an electrical device having some more advantages than Tomlinson surface meter. Now we are coming to the last instrument, which is profilometer. This is a handy device, so it is a compact device you can carry anywhere, and the main advantage of this is it is compact and you can measure the roughness either by moving by your hand or by controlling it electrically. And the main disadvantage of this profilometer is it can't measure perfectly the roughness, waviness, finally the finishness of the particular surface structure. Fine. So now coming to the outer mechanism, how it will be working. Profilometer is a compact device that can be used for the direct measurement of the surface texture. Fine. A finely pointed stylus, here you can see the stylus is in contact with the workpiece. An electrical pickup attached to the stylus. So here you will be having a motor which is used to move this stylus, and also an op-amp will be placed inside this so that it can amplify whatever imperfection is happening here. It can amplify that signals and feed it to either an indicating unit, and here you will be having an indicating unit or a recording unit which is built into this. And moreover, the stylus can be either moved by hand or motorized mechanism can be used. So I'll just show you this original diagram of this profilometer. So this is the profilometer, and here you can place the stylus, and if you just keep the workpiece here, and either by movement of this stylus by electrically operating system, or you can operate it by hand. So these are then emergency conditions if happens. And this is an compactness of an profilometer. It is the main advantage of this profilometer, and it can measure the larger areas. One more advantage is it can measure the larger areas. So finally, the profilometer is capable of measuring roughness together with waviness and any other surface flaws. So whatever the surface is having problems over the surface, it can measure the surface texture. It provides a quick fix of conducting an initial investigation before attempting a major investigation of the surface call. That's what I have told you. So before, if you are, it can't measure the surface texture perfectly. It can only measure the outer layer, what is happening over that surface texture, but it can't go more detailedly. This is the main disadvantage of this. So if you just want to go for a detailed roughness or heaviness over a particular surface, then you can go with an previous two instruments, Tomlinson or tile surf. So this is a compact device, profilometer. So it provides a quick fix means of conducting an initial investigation before attempting a major investigation of surface quality. Now coming to the wavelength, frequency and cutoff. Generally, what is meant by measuring traverse length? If any instrument it travels over a particular workpiece, then that particular length will be calling it as a measuring traverse length. Here you can see that the complete traverse length of the stylus instrument is called the measuring traverse length. So generally this traverse length is divided into sampling lengths. The sampling length depends upon the surface which you are testing. If you need an accurate values, then the sampling rate should be more. If you need a normal value, then the sampling rate will be less. And there is some situations where how much you are doing the sampling rate, the result will be same. In that case, you can prefer the normal sampling rates. Generally, results, the instruments generally they will be doing an average of this measuring traverse length. Okay, it will take the average of all the samples. It will take the average of all the samples and a final value will be coming. And one more thing is, generally the skid is used to give the support to the stylus, right? So skid simplify surface assessments which while using stylus instruments. So there will be some distortion between the skid and the stylus. So because of the distortion, there will be a phase difference between the stylus and the skid. Here you can see in the KC, the skid and stylus are in same phase. In the sense, the stylus is also in the pit and the skid is also in the pit. So both are in the falling side. So there won't be much distortion for the measured value. But in case B, if you just see, my skid is at rising end and the stylus is at falling end. So this makes a huge difference and a distortion for the measured value. In the case C also, the similar thing happened. My skid is on the falling side, my skid is at rising end and stylus is at the falling end. So the distortion and the phase difference will be there between the skid and the stylus. Since the skid, like the stylus, is also rising and falling according to the surface aspirants, stylus height measurement may be distortioned. Therefore, care must be exercised for the selection of the sampling length. Okay. So, if there is a huge distortion, then my sampling rate should be more. If there is a less distortion between the skid and the stylus, then the sampling length should be less. Now, coming to the cutoff wavelength, the frequency of the stylus movement as it rises up and down the workpiece surface is determined by the traversing speed. What is meant by the traversing speed? The relative speed with the workpiece and the instrument is nothing but the traversing speed. If f is the frequency of the stylus movement and lambda is an surface wavelength and v is the traverse speed, then f equal to v by lambda. If v remains constant, f is inversely proportional to lambda. So frequency is inversely proportional to the wavelength. For surface produced by the single point cutting tool, a simple guideline for selecting cutoff wavelength is that it should not exceed 1 feet spacing. This is very important. So if it is a single point cutting tool, the cutoff wavelength it should not exceed 1 feet spacing. Generally, for many fine irregular surfaces, a cutoff length of 0.8 mm is recommended. This is granted that for fine irregular surfaces, the cutoff wavelength will be 0.8. They will be taking 0.8 as an granted and they will start measuring the roughness or waviness. That's all guys. This is the end of the chapter 5, and I think so only 1 or 2 instruments are remaining for the measurement of the roughness. So those are, according to me, those are not that much important. Anyhow, I'll be providing a PDF for that. So from tomorrow's class, I'll be starting chapter 5. Thank you.